Hey guys, tonight we are venturing deep into the mists of time, to a civilization that flourished thousands of years ago along the fertile plains of a mighty river. We're heading to the Indus Valley, home to some of the world's earliest and most enigmatic cities. Picture yourself standing on the edge of an ancient, sun-baked metropolis, its buildings stretching out in an anachronistically orderly grid. The air is thick with the scent of dust, distant cooking fires, and an almost palpable sense of history. And beneath your feet, hidden from immediate view, lies a secret that we're going to unpack tonight. A system of urban water management so sophisticated, so surprisingly modern. It will make you rethink what you thought you knew about the ancient world. Seriously, if you were suddenly transported there and had to rely on their public works instead of your familiar conveniences, you might be shocked at how advanced they were in some areas. Though, let's be honest, without your smartphone, a decent water filter, and a working knowledge of their undeciphered script, you probably won't survive this particular trip back in time for very long anyway. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. It's a small click for you, but it makes a big difference in helping these stories reach other curious minds. And, as always, I'd love to know where you're listening from and what time it is in your part of the world. Drop a comment below. It's always fascinating to see our global community. Now, dim the lights. Maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Imagine the vast, flat expanse of what is now Pakistan and northwestern India, the mighty Indus River. Lifeblood of this ancient land, snakes its way across the plains, fed by its numerous tributaries. The sun beats down, the air often dry and dusty, but along these riverbanks, life has thrived for millennia. It's here, around 4,500 years ago, that one of the world's great early urban civilizations blossomed, almost as if appearing out of nowhere, fully formed and remarkably organized. This is the Indus Valley Civilization, or as it's sometimes called, the Harappan Civilization. After Harappa, one of its major cities, and when I say vast, I mean it, the Indus Valley Civilization flourished around 2500 to 1900 BCE, covering an enormous area, larger than ancient Egypt and Mesopotamia combined, making it one of the most widespread urban cultures of the ancient world. You find yourself approaching the remains of one of its great urban centers, perhaps Mohenjo-Daro, the Mound of the Dead, or the aforementioned Harappa. Even in ruins, there's an undeniable sense of order. No haphazard jumble of streets here. Instead, you see broad main avenues, laid out on a surprisingly regular grid, intersected by smaller lanes, all remarkably consistent. The buildings, predominantly constructed from standardized, baked bricks, millions upon millions of them, further enhance this feeling of careful planning. It's like an ancient city planner with a very serious, almost obsessive passion for straight lines and right angles was given free rein. No. That residential block is 3 centimeters off the designated alignment. Dismantle it and redo it. My reputation for impeccable urban geometry is at stake. Yet, despite this evident order, the Indus Valley Civilization remains profoundly enigmatic in many ways. Their script, a beautiful collection of intricate symbols found on small steatite seals and pottery, remains undeciphered. Generations of scholars have pored over these tiny inscriptions. But their meaning, the language they represent, still eludes us. It's frustrating for historians trying to piece together their beliefs and governance, but it's undeniably great for anyone wanting to let their imagination run wild with theories. This particular squiggle of a fish next to a unicorn-like creature clearly means beware of the particularly grumpy water buffalo down by the river access point, number 3. Who's to say you're definitively wrong until we crack the code? The nature of their society is also a subject of much discussion. How were these vast cities, spread over such a huge territory, governed? Was it a unified empire under a single ruler? A collection of independent city-states sharing a common culture, or something else entirely? Perhaps a form of governance we don't even have a modern name, for archaeologists continue to debate the exact nature of the Indus political structure, whether it was a unified empire, a collection of city-states, or something else entirely, like a system of regional elites bound by shared cultural and economic ties, the usual trappings of overt kingship found in Egypt or Mesopotamia, like grandiose royal tombs, monumental palaces clearly identifiable as belonging to a supreme ruler, or boastful inscriptions detailing royal conquests are conspicuously absent here. It makes for a fascinating puzzle. Imagine being one of the early archaeologists in the 1920s, like Sir John Marshall or R.D. Banerjee, suddenly uncovering these vast, orderly cities after millennia of them being largely forgotten by the wider world. It's like pulling back a thick, dusty curtain from the stage of history and finding evidence of a whole, incredibly advanced civilization that had its grand party, achieved remarkable things, and then quietly exited without leaving an easily readable instruction manual or guest list. The initial shock of this discovery was so profound, the civilization so unique, and its script so opaque, that it led to some rather imaginative early speculation. Early excavators were so puzzled by the IVC's sophistication and undeciphered script that some wildly speculated about connections to the Sumerians in Mesopotamia, or even to entirely mythical lost continents like Lemuria or Atlantis. It's always lost continents, isn't it? When something doesn't neatly fit preconceived notions. Simpler, perhaps, for some to imagine far-flung origins than to fully accept that a local indigenous civilization could be so incredibly clever and organized all by itself, developing its own unique trajectory. But as you wander these ghostly, grid-like streets, as you observe the uniformity of the bricks, the planned layout, you start to sense that this level of organization must have extended to aspects of daily life that are not immediately visible. And one of the most critical aspects of life in any densely populated city, ancient or modern, is the management of water. Water is life, especially in a region dominated by a great river system and subject to seasonal monsoons. The Indus and its tributaries provided water for drinking, for agriculture, for transport. But water also presents challenges: how to dispose of wastewater, how to deal with storm runoff, how to ensure a clean supply for a large population, and it is here, in the realm of urban water management, that the Indus Valley civilization truly excelled, in a way that was virtually unparalleled in the ancient world for its time. We think we're so clever today with our smart homes and our complex municipal infrastructure. But these people, 4,500 years ago, were implementing principles of urban sanitation and water engineering that would not be commonly seen again in many parts of the world for millennia. It puts your perpetually leaky bathroom faucet or that slightly dodgy drain in your kitchen sink into a rather humbling historical perspective. Hidden beneath the streets, integrated into the very fabric of the houses, lies evidence of a system so thoughtful, so comprehensive. It's nothing short of astonishing. We're talking about bathrooms in individual homes, about toilets, about covered street drains, about systems for managing both wastewater and fresh water, with a degree of foresight that is simply breathtaking for its era. This isn't just a few random channels dug into the ground. This is evidence of a sophisticated, citywide approach to sanitation and public health. As you stand there, amidst the silent, sun-drenched ruins, let your imagination drift below the surface. Picture the bustling life that once filled these streets, and then consider the unseen networks beneath, quietly and efficiently performing their vital functions. This is the secret we are here to uncover tonight. The surprisingly complex, remarkably advanced drainage and water systems of the Indus Valley cities. It's a story of engineering prowess, of civic planning, and of a deep understanding of the importance of hygiene and water management. Long before such concerns became widespread, it's a journey into a world where the flow of water, both clean and used, was as carefully considered as the layout of the grandest public buildings. And believe me, the details are going to make you flush with admiration, or at least mild historical awe. And yes, the details of their water management are indeed going to make you flush with admiration, or at least a profound sense of historical awe, because this wasn't some accidental piece of good fortune. No happy coincidence of geography and rudimentary engineering. The sophistication we're about to explore was born from foresight, from meticulous planning, and from an understanding of urban living that was centuries ahead of its time. Before we even look at the first drain pipe or peer into a single bath, you need to understand that these systems were not an afterthought, not a later addition to already existing cities. No, in the Indus Valley, the drainage was part of the grand design, woven into the very fabric of their urban centers from their inception. Their city grids were literally guiding the water. You see, when you approach the remains of a major Indus city, like Mohenjo-Daro or Harappa, one of the first things that strikes you, as we touched upon, is the sheer orderliness. Major Indus cities like Mohenjo-Daro and Harappa exhibit a remarkable degree of urban planning, with streets laid out in a grid pattern and sophisticated drainage systems incorporated from their earliest construction phases. This wasn't your typical ancient city that grew organically, sprawling outwards like an amoeba with winding alleys and haphazardly placed buildings. These were cities conceived with a clear plan. Main streets, often impressively wide, tend to run on a north-south and east-west axis, creating a remarkably regular gridiron pattern. You could probably give directions using a sort of ancient coordinate system. Excuse me, friend, could you direct me to the esteemed beadmaker's workshop? Certainly. You just proceed to North Street number 3. Take a right onto East Lane number 7. It's the third dwelling past the particularly well-constructed public culvert. You can't miss it, unless you're easily distracted by the remarkable uniformity of our kiln-fired bricks. This commitment to order extended to the very building blocks of the city. The Indus people were masters of brick-making. not just any old sun-dried mud bricks that would dissolve in the first heavy rain. Mind you, they mass-produced kiln-fired bricks, incredibly durable and, astonishingly, often of standardized sizes and proportions, not just within a single city, but across different cities separated by hundreds of miles. This uniformity is so striking that it led some early observers to jest that the Indus civilization must have had a highly efficient, if somewhat humorless, Imperial Bureau of Standards and Brick Quality Control. Imagine the ancient brick inspector, armed with a primitive measuring rod and a stern expression. This brick is precisely 2 millimeters, too short, unacceptable. Do you want our drains to leak and our entire advanced urban civilization to be subtly mocked by slightly damp future historians with a penchant for precision? I thought, not back to the kiln with you. Their cities were often divided into distinct sectors. Typically, there was a raised area, often to the west, known as the Citadel or Acropolis. This area usually contained larger public buildings, granaries, perhaps assembly halls, and what appeared to be significant ceremonial structures, like the Great Bath at Mohenjo-Daro, which we'll definitely be dipping our toes into later. Below this, to the east, lay the lower town, a much larger area comprising the main residential and commercial districts, also laid out on that same meticulous grid. This level of consistent urban planning across such a vast territory implies a strong degree of shared cultural norms, and perhaps a centralized authority, or at least a very influential school of urban design. It certainly wasn't a case of, let's just build a hut here and see what happens. Maybe a street will form eventually. This was measure twice, cut once, and for heaven's sake, make absolutely sure the main drain slopes gently but consistently downhill, kind of meticulous planning. And this is where the drainage systems come into the picture, not as a later improvement, but as an absolutely integral component of this initial urban blueprint. The streets weren't just laid out for ease of movement or aesthetic regularity. They were designed to accommodate sophisticated drainage channels from day one. Before the first house was built, before the first brick was laid for a wall, the planners seem to have considered where the water would go. The gentle but deliberate slope of the streets, often leading towards larger drainage outlets, is a testament to this foresight. The houses themselves were oriented and constructed to connect with this public drainage network. As we'll see in more detail, many dwellings had their own private washing areas or bathrooms, and the wastewater from these facilities was often channeled through terracotta pipes or brick-lined drains that ran from the house, under the laneway or street, and into the main covered street drains. This wasn't just a case of digging a hole in the backyard. This was integrated plumbing, Harappan style, for the Indus planners. Good drainage wasn't just a nice-to-have feature. It was clearly a non-negotiable, top-of-the-city planning PowerPoint presentation, must-be implemented everywhere kind of priority. Anachronistic humor aside, the commitment is evident. This foresight is truly remarkable when you compare it to many other contemporaneous ancient civilizations, or even much later cities in other parts of the world. In many ancient urban centers, sanitation was often a far more ad hoc affair. Wastewater might be thrown into the street. Refuse might pile up in alleyways. And formal drainage systems, if they existed at all, were often rudimentary or limited to palaces and temples. Meanwhile, in some of those other ancient places, drainage often simply meant kick the problem into the nearest alley and sincerely hope a passing goat, a stray dog, or a particularly absorbent patch of dirt deals with it. The Indus people, by contrast, were clearly operating on an entirely different level of civic responsibility and engineering prowess. They were thinking systematically, on a city-wide scale, the very materials used for the drains, from the earliest phases of these cities, speak to this intention. Those durable, kiln-fired bricks were not just used for house walls, but were also the primary material for constructing the drains themselves, often carefully bonded with gypsum mortar, and sometimes even lined with bitumen for waterproofing. Though we'll get more into those material specifics later, the point here is that they built their drains to last, to function efficiently, and to be an enduring part of the urban infrastructure. The consistency of these features across different Indus sites, from the metropolises of Mohenjo-Daro and Harappa to smaller towns and settlements, is another indicator of this deep-rooted planning tradition. It suggests a shared knowledge base, a common set of engineering principles, and a widely accepted understanding of the importance of sanitation. This wasn't just one brilliant engineer having a good idea in one city. This was a civilizational approach to urban living, the degree to which the striking uniformity in urban planning and material culture, including these drainage systems, across the vast Indus region reflects a centralized imperial authority versus a shared cultural or ideological system. Without strong political unification is a topic of ongoing discussion among archaeologists. Was there a Harappan empire dictating these standards, or was it more like a widely adopted best practice, shared among interconnected but politically distinct communities? The jury is still out, but the result on the ground, or rather under the ground, is undeniably impressive. These Harappan visionaries were playing 4D chess with urban infrastructure, particularly water management, while some other parts of the world were, metaphorically speaking, still figuring out how to draw a reasonably straight line with a piece of charcoal. Okay, perhaps that's a slight exaggeration for effect, but their dedication to integrating drainage and sanitation into the very DNA of their cities was genuinely ahead of its time. They understood that a well-ordered city wasn't just about straight streets and uniform bricks. It was about managing the essentials of life, including the less glamorous but utterly vital aspect of wastewater disposal, with foresight and skill. This foundational planning, this gridded layout that guided not just people but also water, set the stage for the incredibly sophisticated and specific drainage features that we're going to explore next. It all started with the plan. Yes, it all started with the plan. That remarkable gridded layout that guided not just the feet of the Indus people, but also the vital flow of water through their cities. This foundational planning set the stage for an incredibly sophisticated approach to daily life. And now we're going to zoom in, to step across the threshold of an ancient Harappan home and discover the surprisingly modern comforts and ingenious engineering that lay within. Because the sophistication of the Indus Valley's water management didn't just stop at the main street. It extended right into the private dwellings, offering a level of sanitation and convenience that was truly exceptional for its time. Prepare to be impressed by ancient home comforts and some very clever pipes. As you wander through the residential areas of a city like Mohenjo-Daro, you'd notice that even relatively modest houses often possessed features that we might take for granted today, but which were revolutionary 4,500 years ago. Many houses in Indus cities like Mohenjo-Daro and Harappa contained dedicated bathing platforms and latrines, often connected by drains to the main street drainage system, indicating a high level of importance placed on personal and household sanitation. That's right, we're talking private bathrooms. Imagine your own designated bathing area in 2500 BCE. That was true luxury back then. No more trudging to the river for every wash. No more queuing for a communal trough in the town square, if such things even existed in a less organized fashion elsewhere. You could actually enjoy a bit of privacy. Perhaps even sing in the carefully brick-paved washing area, if you were so inclined. These bathing areas were typically located in a room adjacent to the entrance of the house or near the household well, if one was present. The floors were often meticulously paved with tightly fitted baked bricks, sometimes with a slight slope towards one corner or a specific outlet. This wasn't just a damp patch of earth. It was a purpose-built facility. Water for bathing would likely have been brought in by hand in pottery jars, perhaps from a nearby public well or a private well within the courtyard of a larger house. After use, the wastewater didn't just seep into the ground or get tossed out the window. Oh no, that would be far too uncivilized for the Harappans. Instead, it was carefully channeled away through a dedicated drain built into the floor or wall, often leading directly out of the house and into the waiting street drainage system. And what about the even more, shall we say, pressing needs of daily life? Yes, the Indus people had facilities for that too. Evidence of toilets or latrines has been found in many houses. Now, don't picture the gleaming porcelain throne with a super-efficient dual-flush system you might be accustomed to. We're talking about more rudimentary, but still highly effective, solutions. These often took the form of brick-built commodes or seats, sometimes with a vertical chute or channel leading downwards. In some cases, these chutes connected to a covered drain that exited the house, while in others, they may have emptied into a pottery jar or a small sump pit dug beneath the toilet area, which would then have been periodically cleaned out. Progress. People. Progress. A dedicated spot, often with a system for waste removal, was a significant step up from simply finding a secluded bush on the outskirts of town. The ingenuity of their home plumbing, effectively linking these private facilities to the larger public network, is truly something to behold. It's like every Harappan homeowner attended a mandatory basic hydraulics and responsible wastewater disposal for dummies workshop. Very civic-minded. These ancient folk. Wastewater from the bathing platform, and in some cases from the latrine, would flow through terracotta pipes or carefully constructed brick-lined channels. These conduits often pass through the thickness of the house walls or beneath the floor, emerging outside to connect with a covered drain running along the side of the lane or street. Think about the precision required. The drains within the house had to be sloped correctly to ensure flow. The connection point to the street drain had to be properly aligned. This wasn't just a haphazard hole poked through a wall. It was an integrated system, designed to carry waste away from the living spaces efficiently and hygienically. Some of the terracotta pipes discovered are remarkably well made, often with tapered ends so that one section could fit snugly into the next, forming a relatively watertight conduit. This leads us to a rather quirky or fringe tidbit. The craftsmanship of these interlocking pipe sections is so neat, so almost standardized in some instances, that it's tempting to humorously speculate if they had an ancient Harappan hardware emporium, with aisles dedicated to different plumbing components. Welcome to Harappan Hardware Aisle 3 for our latest range of interlocking terracotta downspouts. Aisle 4 for perfectly angled drain bricks and sump pot lids. Don't forget your Indus Valley loyalty card for a 5% discount on all kiln-fired items. The very presence of such private sanitation facilities in a significant number of ordinary houses is what sets the Indus Valley civilization apart from many of its contemporaries. In ancient Egypt or Mesopotamia, while palaces and temples might have had some rudimentary drainage or bathing areas, such features were far less common in the dwellings of the general populace. The Harappans seem to have democratized sanitation to an unprecedented degree for the Bronze Age. The exact mechanisms and social norms surrounding the use and cleaning of private latrines, and whether all segments of the population had truly equal access to such sophisticated facilities, or if there were variations based on wealth or status within different neighborhoods, are still areas of ongoing research and interpretation by archaeologists. Did absolutely everyone have an ensuite bathroom and a personal loo? Probably not the apprentice brickmaker living in the most modest quarters. But the fact that so many did, across different sizes of houses, is still pretty mind-blowing for a civilization that flourished over 4 millennia ago. This widespread concern for household hygiene and waste management speaks volumes about the values and priorities of Indus society. It suggests a population that understood the importance of cleanliness, not just for comfort, but perhaps also for health. By channeling wastewater away from their homes and into a managed public system, they were actively reducing the risk of contamination and disease, creating a more salubrious urban environment for everyone. The individual household, therefore, wasn't an isolated unit when it came to sanitation. It was a vital node in a larger, interconnected network. The responsibility for managing wastewater didn't end at the outer wall of the house. It was a shared civic undertaking. This level of integration, this seamless connection between private facilities and public infrastructure, is one of the defining characteristics of Indus urbanism, and a key reason why their drainage systems are considered so remarkably advanced. It's a beautiful example of individual convenience meeting communal responsibility, all engineered with simple yet effective materials and a deep understanding of how water behaves. And as this wastewater left the individual homes, its journey was only just beginning, as it entered the even more impressive network of drains that ran beneath the city streets, and as this wastewater, this effluent from countless private bathrooms and latrines, left the individual Harappan homes, its journey was indeed only just beginning. It flowed out, not into open gutters or stagnant pools, but into an even more impressive and meticulously engineered network, the main public street drains. These were the subterranean streams of the Indus cities, a hidden testament to their builders' extraordinary commitment to sanitation and civic planning, running beneath the very thoroughfares you'd walk upon. So, you're strolling down one of those remarkably straight, wide main streets in Mohenjo-Daro. perhaps admiring the uniform baked brick houses on either side. What you might not immediately realize is that beneath your feet, or running neatly alongside the edge of the street, is another marvel of Harappan engineering. Indus Valley cities had extensive networks of covered street drains made of baked bricks, which were precisely sloped to carry wastewater away from residential areas. These weren't just ditches. They were carefully constructed channels, a citywide system designed for efficiency and, remarkably, for the ancient world, for public hygiene. Imagine peeling back the surface of the street like lifting a lid. There you would see it a robust channel, typically rectangular or U-shaped, built with those same high-quality, kiln-fired bricks that characterize Indus architecture. The brickwork is often exceptionally skilled, with bricks laid carefully, sometimes with multiple courses to achieve the desired depth and strength. In many instances, these drains were substantial, some of the main collectors being large enough for a person to walk through, if they were so inclined and didn't mind the ambiance, though importantly, they were usually covered. That's right, covered drains. This was a crucial feature. The Harappans topped their street drains with large, flat-baked bricks or substantial stone slabs, creating a surface that could be walked or driven upon presumably by ox carts, not a Ford F-150. This simple but brilliant innovation meant that the streets remained usable and relatively clean, without the hazard and stench of open sewers that plagued so many other cities throughout history, even much later ones. Thoughtful, wasn't it? And it probably saved a small fortune on ancient ankle sprain treatments and dramatically reduced the chances of an unexpected and deeply unpleasant tumble on your way to the local granary or bead emporium. The engineering involved in these street drains is where the Harappan genius truly shines. It wasn't just about digging a channel and hoping for the best. These systems were precisely engineered with gentle but consistent gradients. The slope was paramount. If it was too steep, the water might flow too quickly, potentially causing erosion or leaving solids behind. If it was too shallow, or worse, sloped the wrong way, you'd end up with a stagnant, smelly, overflowing mess. A Bronze Age sanitation crisis. The Harappan engineers clearly understood this. The slopes of these drains were so carefully calculated, often over considerable distances. You can just imagine the pressure on the ancient civil engineers. Okay, team, this main drain needs to drop exactly 1 centimeter for every 5 meters for the next half a kilometer. A few degrees off, and we've got a very unpleasant, highly fragrant, and politically embarrassing situation on our hands. No pressure, but the entire city's hygiene, public health, and my continued employment as chief drain designer are depending on your impeccable math and leveling skills. The way these drains interconnected is also a marvel. Smaller drains from individual houses and narrower side lanes would feed into these larger street drains. At junctions, the connections were often made with smooth curves rather than sharp, right-angled turns. This seemingly small detail is incredibly important. Smooth curves help to maintain the flow of water and prevent debris from accumulating and causing blockages. It shows a sophisticated understanding of hydraulics. The brickwork in these drains, particularly at the junctions and curves, is often so good, so precisely executed. It puts some modern municipal efforts to shame. You can almost picture a grizzled Harappan master mason squinting at an apprentice's work. No, Utnapishtim Jr., that brick isn't quite flush. The curve isn't smooth enough. Do you want our vital subterranean streams to snaggle and back up, causing untold inconvenience and olfactory distress to the esteemed citizens of Ward 3? I think not. Do it again, and this time with feeling and a better understanding of fluid dynamics. Some of these main drains were surprisingly deep, dug well below the street level, ensuring that even during periods of heavy use or moderate rainfall, they had the capacity to carry the load. This brings us to a rather fascinating, quirky, or fringe tidbit about their construction in some sections, especially where drains had to be particularly robust or covered over a wider span. Excavators have found evidence of quite sophisticated bricklaying techniques, such as small arched sections or corbelled roofs built over the channels. These weren't true keystone arches in the Roman sense, but they represent an ingenious way of using bricks to create a strong, self-supporting cover, almost like miniature underground tunnels. It's another subtle indication of their advanced masonry skills and their commitment to building infrastructure that was both functional and durable. And this wasn't a system confined to just the elite citadel areas or a few privileged neighborhoods. This network of drains extended throughout the lower town, serving the wider population. The sheer scale of it is staggering when you consider the technology available. Kilometers of these covered, brick-lined channels, all carefully sloped, all interconnected, all designed to keep the city clean and functioning, even with their covered design. Let's be realistic. A Bronze Age city, however well drained, probably didn't smell like a field of roses on a spring morning. But this comprehensive system would have made a colossal difference compared to cities without such infrastructure. Far less eau de open sewer, much more eau de slightly damp earth, wood smoke from cooking fires, and perhaps the distant, intriguing scent of spices from the marketplace. A significant improvement. I'm sure you'll agree. How did they achieve such precision in laying out these long, gently sloping drains without the benefit of modern laser levels, theodolitis, or GPS surveying equipment? The exact methods used by Indus engineers to achieve such consistent gradients over long distances without modern surveying equipment are still being studied, though careful observation and simple leveling tools were likely key. They might have used water levels, a simple trough filled with water to find a true horizontal, or plumb bobs to ensure verticality, and perhaps sighting along long lines or using marked posts to establish gradients. It would have required immense patience, a keen eye for detail, and probably a lot of trial and error in the early days. With knowledge being refined and passed down through generations of builders, is it perfectly downhill yet? Ugh, my kingdom for a reliable spirit level, and perhaps a slightly less argumentative apprentice, when archaeologists first began to systematically unearth these Indus cities in the early 20th century. The discovery of these extensive and sophisticated drainage systems was a revelation. It shattered preconceived notions about the level of urban development in such ancient societies. Imagine the scene carefully brushing away centuries of accumulated earth and debris to reveal these perfectly constructed brick channels, still largely intact, still showing the unmistakable signs of intelligent design. Well, I'll be. One can almost hear the chief archaeologist exclaiming, "This isn't just a random collection of old bricks. This street seems to have its very own secret underground brick river, complete with inspection covers. How incredibly neat is that, perhaps an understatement of the archaeological millennium. These subterranean streams, these hidden arteries of the Harappan cities, tell a story of a people who valued order, hygiene, and communal well-being. They demonstrate a level of foresight and engineering skill that was truly exceptional for their time, laying a foundation for urban life that allowed their cities to thrive for centuries. And, as we'll see, their ingenuity didn't stop at simply channeling the water away. These subterranean streams, these meticulously engineered hidden arteries of the Harappan cities, truly do tell a profound story of a people who valued order, hygiene, and communal well-being far beyond what was common for their era. Their foresight in laying a foundation for urban life that allowed their cities to thrive for centuries is undeniable. And, as I hinted, their ingenuity didn't just stop at efficiently channeling the wastewater away from homes and through the streets. The next logical question, as you trace this winding path of ancient effluent in your mind, is where did it all go? What was the final destination for these carefully managed flows? Did it all just pour into the nearest river? Or did the Harappans have even more sophisticated methods up their well-made sleeves? So, all this carefully channeled wastewater, a mixture from countless bathing platforms, latrines, and perhaps even some workshop activities, having made its journey through private drains and into the main public arteries. Where did it ultimately end up? Did it go on a lovely, albeit slightly fragrant, tour of the surrounding countryside? Or did it have a more contained, perhaps less glamorous, final resting place? The answer, as with many things about the Indus Valley civilization, appears to be a combination of well-thought-out strategies, rather than a single, simple solution. In some instances, particularly in cities located close to major rivers or other large bodies of water, evidence suggests that main drains were indeed directed towards the outskirts of the city, likely with the intention of discharging their contents away from the populated areas. Wastewater from Indus cities was often directed towards the city outskirts, or into large soakage jars or sump pits, where solids could settle and liquids could seep into the ground, indicating a system for both conveyance and a form of primary treatment or disposal. The final outfall points of these larger drains can sometimes be difficult to pinpoint with absolute certainty today, as millennia of erosion, flooding, and changes in the landscape may have obliterated the evidence. However, the orientation of the major drainage arteries often strongly suggests a deliberate attempt to lead the wastewater out and away. Now, you might be thinking, discharging it into the river isn't that a bit polluting? By modern standards, yes. Untreated wastewater discharge is a huge environmental no-no. However, we have to consider the context of the Bronze Age. The population densities, while high for their time within the cities, were minuscule compared to today. The rivers, like the mighty Indus, were vast and powerful. It's possible that the dilution factor was considered sufficient, or perhaps their understanding of waterborne diseases and downstream impact was, understandably, not as developed as ours. Or perhaps they had other methods in play to mitigate this. One of the most ingenious and commonly found solutions for dealing with wastewater, particularly from individual houses or smaller street drains before they joined the main collectors, or even at the terminus of some drainage lines, was the use of sump pits or soakage jars. Imagine a large cylindrical pottery jar, often several feet deep, buried in the ground. Drains would empty into this jar. The idea was beautifully simple, yet effective, as the wastewater flowed in. The heavier solid particles would settle at the bottom of the jar. The liquid component, meanwhile, could gradually seep out through the porous earthenware of the jar itself, or through holes deliberately made in its lower sections, or even overflow from the top into a surrounding soak pit filled with gravel or broken pottery, allowing it to filter slowly into the surrounding earth. These were, in essence, ancient septic tanks or soakaways. These sump pits weren't just a set-it-and-forget-it solution. They would have required periodic maintenance. Once a jar became substantially filled with settled solids, it would need to be cleaned out. Archaeologists have found evidence of this. Jars containing layers of accumulated silt and organic matter, and sometimes even implements nearby that might have been used for scooping out the contents. Imagine the job posting for that particular role in ancient Harappa. Wanted sump pit custodian. Must possess a robust constitution, an exceptionally strong stomach, preferably long arms, and a can-do attitude towards, well, you know. Previous experience with malodorous materials an advantage, but not essential. Perks, all the slightly used but historically significant broken pottery you can carry, and the undying gratitude of your less olfactorily challenged neighbors. It wouldn't have been the most glamorous job in the city, but it was absolutely vital for the continued functioning of the entire sanitation system. Some of these terracotta collection jars are impressively large, big enough, in fact, to lead to some rather quirky or fringe tidbit-style speculation. People have jokingly wondered if these capacious buried vessels were occasionally commandeered as impromptu hiding spots by mischievous Harappan children during a particularly energetic game of hide-and-seek. Picture it. A tiny voice calls out, "Ready or not, here I come," followed by muffled Harappan giggling emanating from deep within a sump pot. Probably not their intended primary use, and certainly not a recommended play area, but one can imagine kids throughout history finding inventive, if sometimes ill-advised, uses for an intriguing hole in the ground. Their actual purpose, of course, was far less playful and far more crucial to urban hygiene. Beyond these larger sump pots, there's also evidence of smaller sedimentation tanks or grit chambers built into the drainage system itself. These were essentially small basins or traps designed to catch coarser debris, sand, and grit before the wastewater entered the main channels or flowed into a soak pit. By allowing the heavier particles to settle out in these easily accessible traps, the Harappans could prevent their main drains from silting up too quickly and reduce the frequency with which the larger sumps needed cleaning. It's another example of their thoughtful, multi-stage approach to wastewater management, dealing with the problem incrementally. So, it seems the Indus people likely employed a multi-pronged approach. Some wastewater, perhaps from the largest arterial drains, might have been channeled out of the city entirely. Other flows, especially from individual dwellings or smaller neighborhood systems, were directed into these clever sump pits and soakaways for a degree of on-site treatment and dispersal. The exact final destination of all wastewater from the largest Indus cities, such as Mohenjo-Daro with its vast population, and the extent to which any of it may have been systematically collected and used for purposes like irrigation in nearby agricultural fields, or if it was simply allowed to discharge into surrounding lowlands or natural watercourses, remain topics of ongoing investigation and active discussion among archaeologists. Using nutrient-rich wastewater for irrigation would certainly have been an incredibly efficient form of ancient recycling. Don't just throw out that murky bathwater citizen. The burgeoning sorghum crop down by the south gate is looking a bit thirsty and could use the organic boost. While there's no definitive, widespread proof of large-scale wastewater irrigation systems directly linked to the urban drains, it's a tantalizing possibility that fits with their generally pragmatic and resourceful character. What is clear is that these systems were designed to remove waste from the immediate living environment with remarkable efficiency. This would have had a hugely positive impact on public health within the cities, reducing the prevalence of diseases associated with poor sanitation. Whether they fully understood the germ theory of disease is unlikely, but they clearly recognized a connection between cleanliness, waste removal, and well-being. Their approach was far more proactive than simply hoping the problem would magically disappear. Where did all of it ultimately go? Every last drop. Some of those finer details might remain elusive, buried under millennia of silt and societal change. Perhaps there's a secret Harappan wastewater dimension that archaeologists just haven't stumbled upon yet. Highly unlikely, of course, but it certainly keeps the imagination ticking over and reminds us that there are always more secrets for these ancient cities to yield. The wastewater's winding path, from the private home, through the covered street drain, and towards its final managed dispersal, showcases a level of planning and execution that is truly astounding for the Bronze Age. It wasn't just about getting it out of sight. It was about managing it responsibly, at least within the context of their knowledge and capabilities. And this careful attention to the outflow was beautifully complemented by an equally sophisticated approach to the inflow, the provision of fresh, clean water. The wastewater's winding path in those ancient Indus cities, from the private home through the meticulously engineered street drains and towards its managed dispersal, truly does showcase an astounding level of planning for the Bronze Age. It wasn't just about getting waste out of sight. It was about managing it responsibly. And this very careful, very deliberate attention to the outflow of used water was, as you might expect from such a thoughtful civilization, beautifully complemented by an equally sophisticated and vital approach to the inflow, the provision of fresh, clean water. After all, what good is a brilliant drainage system if you don't have a reliable source of clean water to begin with, for drinking, cooking, bathing, and all the other necessities of daily and ritual life? So, let's now turn our gaze from the drains to the fountains of life, the wells and reservoirs of the Indus Valley. Fresh water was and is the absolute cornerstone of any settlement. And for the bustling cities of the Indus Valley, with their thousands of inhabitants, a dependable supply was paramount. You can't have a thriving metropolis without it. This wasn't just for basic survival. The Harappans, as we've seen with their private bathing platforms, clearly valued cleanliness. And as we'll soon see with monumental structures like the Great Bath at Mohenjo-Daro, water also played a significant role in their ritual and ceremonial life. One of the primary sources of this vital fresh water was the good old-fashioned well. But these weren't just any old holes in the ground. Indus cities featured numerous private and public wells, often deep and meticulously brick-lined, for accessing groundwater. And some sites like Dolavira had elaborate systems of reservoirs for rainwater harvesting and storage. Many of the larger, more affluent houses in cities like Mohenjo-Daro and Harappa boasted their own private wells, typically located in a central courtyard or a dedicated room. Imagine the convenience, having your own personal well right in your courtyard. That's the undisputed Bronze Age equivalent of having a top-of-the-line, plumbed-in smart fridge with an ice dispenser and a fancy built-in espresso machine. Oh, this old thing. You can almost hear a wealthy Harappan merchant casually remarking to a visitor, "Just my personal subterranean hydration station. Terribly convenient for the morning ablutions." You know, these private wells were often masterpieces of construction in their own right. They were usually circular, lined with specially shaped wedge or curved baked bricks to ensure a tight, stable structure that wouldn't collapse inwards. Some of these wells were incredibly deep, sunk many meters down to tap into the permanent water table, a testament to the builders' skill and their understanding of local hydrology. The tops of these wells were often finished with coping stones or raised brick platforms to prevent surface runoff from contaminating the water and to make the process of drawing water easier and safer. For those who didn't have a private well, or for communal needs, there were also numerous public wells, strategically placed at intersections or in open public spaces throughout the cities. This ensured that everyone had access to a source of fresh water. The sheer number of wells found in Indus cities is remarkable. Mohenjo-Daro alone may have had over 700 of them. This density of wells is unparalleled in most other ancient civilizations for that period. This clearly indicates that access to clean water was a high priority for the entire community, not just the elite. As you gaze down into the imagined depths of one of these ancient wells, you might notice something quite poignant on the well heads, the bricks or stones forming the rim. This brings us to a rather touching, quirky, or fringe tidbit. Many of these well copings, the sturdy bricks or stones at the top, show deep, smooth grooves worn into their surface over centuries of continuous use. These are rope marks, etched into the hard material by the constant friction of ropes being drawn up and down, day after day, year after year, as countless individuals lowered their pottery jars to fetch water for their families, their livestock, their rituals. These simple grooves are a silent, eloquent testament to the daily labor, the generations of effort involved in the simple, essential act of drawing water. That's centuries of "are we there yet?" but for water buckets, each pull adding infinitesimally to those grooves. Probably did wonders for your upper body strength and grip, though beyond wells, particularly in regions where the water table might have been less accessible or rainfall more seasonal. The Indus people also demonstrated their ingenuity in creating larger water storage facilities like reservoirs and cisterns. The city of Dolavira, located in the arid run of Kutch in modern-day Gujarat, is particularly famous for its truly elaborate system of massive stone-cut reservoirs. These weren't just ponds, they were sophisticated engineering projects designed to harvest and store precious monsoon rainwater. Some of these reservoirs were interconnected, with channels to divert water from seasonal streams or from carefully managed catchment areas into these vast storage basins. This water would then have been crucial for sustaining the city's population and agriculture through the long, dry seasons. It shows an incredible adaptation to a challenging environment. These Harappans were seriously into water conservation long before it became a global buzzword. You can almost imagine little terracotta signs dotted around Dolavira. Every drop counts, especially when it hasn't rained for 6 months and the next monsoon is just a vague promise on the horizon. And no discussion of water in the Indus Valley civilization would be complete without mentioning the Great Bath at Mohenjo-Daro. This truly iconic structure, located on the Citadel Mound, is one of the most famous and well-preserved features of any Indus city. It's essentially a large, rectangular, sunken tank, roughly 12 meters long, 7 meters wide, and about 2.4 meters deep. Not your average municipal swimming pool. Then, it's meticulously constructed from finely dressed baked bricks laid on edge, with a thick lining of bitumen, natural tar, used as a remarkably effective waterproofing agent between the brick courses to prevent leakage. They really didn't want that special bath water seeping out prematurely. This is a highly important, possibly sacred communal dip. People, not a slow, unintentional irrigation project for the underlying foundations. Seal it tight. The Great Bath had steps leading down into it from either end, and it was surrounded by a colonnade and a series of small rooms, some of which may have served as changing rooms or private bathing cubicles. It even had its own sophisticated water supply and drainage system. Water was likely supplied from a nearby well, and there was a large outlet drain, also carefully constructed, to allow the bath to be emptied and cleaned periodically. While its exact purpose is still debated, its careful construction, its prominent location, and the effort involved in maintaining it strongly suggest it was used for ritual or ceremonial purification rather than for recreational swimming. No diving, no splashing, no Marco Polo. Please, sacred rituals in progress. The precise ritualistic functions of the Great Bath at Mohenjo-Daro, beyond general purification, and whether similar large-scale bathing structures existed at other major Indus sites, or if this was unique to Mohenjo-Daro's role, continue to be explored and debated by researchers. What all of this, the countless private and public wells, the impressive reservoirs of Dolavira, the unique Great Bath, demonstrates is a holistic approach to water management. The Indus people weren't just experts at getting rid of wastewater. They were equally adept at sourcing, storing, and utilizing fresh water. They understood its vital importance for every facet of urban life, from basic domestic needs to grand public or ritual displays. Clean water was clearly a priority. No one wants their sacred ceremonial dip or their essential morning drink to taste like last week's, well, anything other than pure, refreshing water. This careful management of both the inflow of fresh water and the outflow of wastewater reveals a remarkably complete understanding of the urban water cycle, at least within the context of their Bronze Age knowledge. It's another layer of sophistication that elevates the Indus Valley civilization to a truly exceptional place in the annals of early urbanism. They weren't just building cities. They were creating sustainable, hygienic, and well-serviced environments for their inhabitants. Indeed, The Indus Valley civilization's holistic approach to water, managing both the inflow of fresh supplies and the outflow of wastewater, truly elevates them into a special category of ancient urban planners. They weren't just building cities. They were meticulously creating sustainable, hygienic, and impressively well-serviced environments for their inhabitants. And a huge part of that success, a critical element in the longevity and efficiency of their sophisticated drainage and water systems, lay in the very materials they chose and the way they prepared them. It's one thing to have a brilliant plan. It's another to have the right stuff to build it with, stuff that can withstand the test of time and the constant presence of water. So, let's get our hands virtually dirty and explore the bricks, the bitumen, and the other components that ensured the remarkable durability of these ancient systems. The undisputed heavyweight champion material in the Indus construction playbook, especially when it came to anything involving water, was the kiln-fired baked brick. We've mentioned these before, but their importance cannot be overstated. Unlike sun-dried mud bricks, which were common in many other ancient civilizations, including, for some purposes, in the IVC itself, particularly for house walls that weren't directly exposed to constant moisture. Baked bricks are a game changer. The process of firing bricks in a kiln at high temperatures transforms the clay, making it incredibly hard, durable, and significantly resistant to water. Sun-dried bricks in a drainage system. That's basically a recipe for a very rapid, very muddy, and ultimately very smelly disappointment. The Harappans knew better. The Indus Valley civilization extensively used standardized kiln-fired baked bricks for constructing their drains, wells, and buildings, a material far more durable and water-resistant than the sun-dried bricks common in many other ancient cultures. Imagine the scene: bustling brickyards on the outskirts of the cities, with kilns belching smoke, turning out literally millions of these high-quality building blocks. And, as we noted, one of the most astonishing things about these bricks is their standardization. They often adhere to remarkably consistent size ratios, typically 1:4 thickness, width, length, not just within one city, but across the entire vast expanse of the civilization. Whether you were in Mohenjo-Daro in Sindh or Harappa in Punjab, hundreds of miles apart, the bricks were often strikingly similar. This suggests a highly organized system of production and a shared understanding of optimal building practices. It meant that construction could be more efficient, plans could be more easily replicated, and the structural integrity of their creations, including those all-important drains and wells, was greatly enhanced. Their bricks were so reliably uniform. You could probably take a randomly selected one from a dig in Mohenjo-Daro, and it would fit almost perfectly into a partially excavated wall in Harappa. Ancient interchangeable parts, very forward-thinking, and a dream for any ancient quantity surveyor. These robust baked bricks were the primary material for lining drain channels, constructing manholes, building bathing platforms, and casing the deep shafts of their wells. Their water-resistant nature meant that the drains wouldn't easily erode or collapse, even with a constant flow of wastewater. Their strength allowed for the construction of surprisingly large and deep channels, some of which have remained structurally sound for over 4 millennia. Now, just stacking bricks, however good they are, isn't always enough, especially when you want to create a channel that guides water effectively. You need something to bond them together, and this is where mortar comes in. The Harappans used different types of mortar depending on the application. For many of the drains, especially the more critical ones, they often employed gypsum-based or lime-based mortars. These would have provided a stronger, more water-resistant bond than simple mud mortar, helping to keep the brick courses stable and reducing leakage. In some less critical areas, or perhaps for the infill between double-walled drains, mud mortar might have been deemed sufficient. The key was having the right kind of sticky stuff to keep it all together. You certainly don't want your carefully laid drain segments deciding to do the conga line down the street every time there's a particularly heavy flow. Everything needed to be neat, tight, and reliably pointing downhill. But what if you need something to be seriously, undeniably waterproof? For this, the Indus people had another ace up their sleeve: bitumen. This is naturally occurring asphalt or tar, a sticky, black, viscous substance that is excellent for repelling water. The most spectacular example of its use is in the Great Bath at Mohenjo-Daro, where, as we mentioned, a thick layer of bitumen was applied between the courses of the finely laid baked bricks of the tank, creating a remarkably effective waterproof seal. This ensured that the vast quantity of water in the bath stayed in the bath, rather than slowly seeping away and undermining the foundations of the surrounding structures. We want this incredibly important ceremonial bath to hold water, people. The chief engineer must have stressed not to gradually transform the esteemed citadel into an unseemly and structurally unsound swamp, while the Great Bath is the most famous example. The exact sourcing and methods of large-scale bitumen procurement and application for waterproofing in structures like the Great Bath, and potentially in some of the more critical drains or sumps, are still being investigated by archaeologists, with theories pointing to local or traded sources. Bitumen occurs naturally in some parts of the region, and it's possible they were exploiting these local seeps, or perhaps it was a valuable commodity traded over longer distances. Its careful application shows a sophisticated understanding of its properties and a commitment to long-term durability in their water-retaining structures. For smaller conduits, particularly those leading from individual houses to the street drains, the Harappans often used terracotta-fired clay pipes. These were typically cylindrical or slightly conical, with sections designed to fit one into another, much like modern drain pipes. Some were straight. Others were curved or L-shaped to navigate corners. These pipes, being made of the same durable baked clay as the bricks, were also resistant to decay and would have efficiently channeled wastewater away from living areas. And, while baked brick was king, stone also played a role, particularly for elements like the robust slabs used to cover the street drains, providing a durable walking surface. In areas like Dolavira, with its massive reservoirs, dressed stone was used extensively in their construction, showcasing a mastery of stone masonry alongside brickwork. It's fascinating to think that sometimes, amidst all this carefully manufactured material, little accidental human or animal touches have survived. This leads to a delightful quirky or fringe tidbit. Some of the baked bricks from various Indus Valley sites bear the accidental imprints of animal paws, often dogs or cats, maybe even a curious mongoose, or sometimes even human fingerprints. captured in the wet clay before the bricks were fired. These tiny, incidental marks, frozen in time for over 4,000 years, provide a wonderfully intimate connection to the past. Imagine a Harappan brickmaker having just laid out a batch of fresh bricks to dry slightly before firing, momentarily turning their back, only to find that a playful puppy or a wandering feline has decided to leave its autograph for posterity. Get off the wet bricks. Fido, you'll ruin my meticulously maintained, standardized dimensions, and possibly become an incredibly specific archaeological curiosity in about 4 millennia. These little imprints make the very material of their civilization quite literally touchable across the vast gulf of time. It was this careful selection and preparation of materials, the strong, water-resistant baked bricks, the appropriate mortars, the strategic use of waterproofing agents like bitumen, and the durable terracotta pipes that ensured the extraordinary longevity of the Indus drainage and water systems. These systems were built to last, and they did. Many of these drains are still remarkably intact today, thousands of years after they were first laid. My own attempts at garden path paving using modern materials barely lasted 3 British winters before succumbing to frost heave and general wear and tear. Clearly, I should have consulted ancient Harappan engineering principles and material science. The material genius of the Indus people underpinned their entire urban vision. They understood that to create a healthy, functional, and enduring city, especially one so focused on the management of water, you needed not just clever designs, but also materials that were up to the task. Their legacy in brick and bitumen is a testament to that understanding. The material genius of the Indus people, their mastery over baked bricks, mortars, and even waterproofing agents like bitumen, truly did underpin their entire remarkable urban vision. They understood that to forge a healthy, functional, and enduring city, particularly one so intricately entwined with the management of water, you needed not just clever designs, but also materials robust enough for the task. Their legacy in brick and bitumen stands as a powerful testament to that profound understanding. But, as anyone who has ever dealt with a clogged kitchen sink or a stubbornly blocked gutter can attest, even the most brilliantly designed and durably constructed system needs regular care and attention if it's to keep functioning effectively. So, how did the Harappans ensure their sophisticated drains remained unclogged and their cities healthy? Let's investigate the potential maintenance access points and the systems they likely had in place for upkeep. It's a simple truth of any drainage system, ancient or modern, over time, things accumulate. Silt carried by wastewater, small debris, organic matter, perhaps even the occasional accidentally dropped personal item. All of these can conspire to create blockages, impede flow, and ultimately cause the system to fail. Even the best engineered Bronze Age drains, built with the finest kiln-fired bricks, could get a bit gunked up after a while. Darling! One can almost hear an exasperated Harappan householder exclaim, "The main street drain outside is backing up again. The aroma is distinctly suboptimal. Someone needs to call the ancient Harappan equivalent of dino rod." And quickly, the Indus people, with their evident foresight in so many other areas, surely anticipated this. A drainage network, however sophisticated, is only as good as its maintenance program. And, indeed, when you examine the layout of their street drains, you find clear evidence that they planned for this necessity. Indus drainage systems included features like brick-lined manholes or inspection pits at regular intervals along street drains, allowing for access to clean out silt and obstructions, indicating a system of regular maintenance. These weren't just accidental gaps. They were purpose-built access points. Imagine walking along a Harappan street. Those stone slabs or large baked bricks covering the main drains weren't necessarily all hermetically sealed. Some could be lifted, providing direct access to the channel below. More impressively, at strategic points, often at the junction of two or more drains, or at regular intervals along a particularly long stretch. Archaeologists have uncovered what can best be described as manholes or inspection chambers. These typically consist of a brick-lined shaft leading down to the level of the drain. Some are square, others circular, often corbelled inwards at the top to reduce the size of the opening, which could then be covered with a stone slab or a sturdy brick. Manholes, or, if you prefer, Harappan holes. It's rather compelling proof that the fundamental concept of something seems to be stuck down there in the dark, smelly depths. We'd better have a designated point to get in and have a look-see is truly timeless. These access points would have been absolutely crucial. They allowed workers to inspect the condition of the drains, to locate blockages, and, most importantly, to physically remove any accumulated silt, debris, or other obstructions. The presence of these features strongly suggests a system of proactive, regular maintenance, rather than just waiting for a catastrophic failure. What about those sump pits and sedimentation traps we discussed earlier? Those pottery jars or brick basins designed to catch solids, they, too, were an integral part of the maintenance strategy. By trapping heavier debris at easily accessible points, they reduced the burden on the main drain channels and localized the cleaning effort. The contents of these sumps would have been periodically scooped out and disposed of, preventing them from overflowing and recontaminating the system. So, what tools and methods would these ancient sanitation workers have used? Their drain cleaning toolkit was probably less high-pressure water jetting tanker and more very long, sturdy bamboo pole with some kind of scoop or hook on the end, combined with a great deal of patience and a strong arm. They might have used specialized pottery scoops, bronze implements, or even just their hands hopefully gloved in some fashion, though we can't be sure to clear out the gunk. Buckets or baskets would have been needed to haul the removed waste up to the street level. It would have been dirty, smelly, and physically demanding work, but absolutely essential for the health and functioning of the city. And where did all this collected sludge and debris go? Presumably, it was transported out of the city for disposal, perhaps to designated refuse areas or even used as fertilizer on agricultural fields, if the organic content was suitable and cultural practices allowed. The logistics of collecting and disposing of this waste from potentially hundreds of access points across a large city would have required considerable organization. This brings us to the question of who was responsible for this vital but unglamorous work. Was there a dedicated municipal body, a sort of Harappan Department of Public Works and Drain Maintenance, staffed by specialized city employees, or was it a more localized, community-based responsibility, with residents of a particular street or neighborhood tasked with keeping their section of the drains clear? The exact frequency and organizational structure of drain maintenance in Indus cities, whether it was a centrally managed municipal task or a more localized community responsibility, overseen by neighborhood elders or officials, remain subjects of ongoing archaeological inquiry and interpretation. Given the overall level of civic organization evident in their city planning and standardized construction, it's certainly plausible that there was some form of centralized oversight or at least a well-established system for ensuring this critical work got done. Someone had to be in charge of the drain MOTs, ensuring each channel was fit for purpose. Right team. Drain number 7B on North Street, by the big granary, is due for its biannual degunking. Nanny, you're on duty this week. Don't forget your nose pegs. It's during the excavation of these drains and sump pits that archaeologists sometimes find little unintentional glimpses into daily Harappan life. This leads to a rather fascinating, quirky, or fringe tidbit occasionally. Small, everyday objects are discovered embedded in the accumulated silt inside these ancient drains. Things like broken pottery shards, unsurprising, but also lost beads, fragments of terracotta bangles, children's small toy cartwheels, or animal bones. These items weren't meant to be there. Of course, they were accidentally dropped, swept in with street refuse, or perhaps mischievously poked through a gap in a drain cover by a curious child. Finding a tiny, beautifully crafted toy cartwheel in the sludge at the bottom of a 4,500-year-old drain. Oops. Sorry, little Timmy. You can almost hear a Harappan parent sighing. It seems your favorite wheeled bullock just embarked on an unexpected subterranean wastewater adventure. It's these tiny, poignant discoveries that remind us these were real people living real lives, occasionally losing things down the drain just like we do today. And it gives us a clue about the kind of miscellaneous debris those ancient cleaners might have had to contend with. The job of a drain cleaner in an Indus city probably wasn't the most prestigious or sought-after profession. There were likely no celebratory parades for the sump scourer of the year, but their work was undeniably vital. By keeping these subterranean streams flowing freely, they were playing a direct role in maintaining the public health and overall well-being of the entire urban population. A well-maintained drainage system meant less standing wastewater, fewer breeding grounds for disease-carrying insects, reduced odors, and a generally cleaner, more pleasant living environment. It's a direct line from unclogged drains to a healthier city. The evidence for regular maintenance, therefore, adds yet another layer to our admiration for the Indus Valley civilization. Their sophistication wasn't just in the initial design and construction of these remarkable systems, but also in their apparent understanding that such infrastructure requires ongoing care and commitment to remain effective. They didn't just build it and forget it. They seemingly built it, and then they maintained it, ensuring that their investment in public health and urban amenity would continue to pay dividends for generations. This foresight, this dedication to upkeep, is perhaps one of an Indus city's most quietly impressive achievements. This foresight in planning for maintenance, this quiet dedication to the ongoing upkeep of their vital drainage systems, is indeed one of the most subtly impressive achievements of the Indus cities. It speaks of a society that didn't just build for today, but for tomorrow, and for the generations to come. But as you pull back your focus from the individual drain pipe, or the single manhole, and consider the Indus Valley civilization as a whole, another layer of its profound sophistication and enigmatic nature comes sharply into view. The striking almost unbelievable standardization of these very drainage and sanitation systems across its vast domain. It wasn't just one city that got it right. It was a civilizational signature. We've talked about the immense geographical spread of the Indus Valley civilization, stretching over 1 million square kilometers across modern-day Pakistan and northwest India. We're talking about major urban centers like Mohenjo-Daro, Harappa, Ganeriwala, Dholavira, Lothal, and Rakhigarhi, often separated by hundreds of miles of rugged terrain, rivers, and plains. And yet, when archaeologists excavate these disparate sites, they find a remarkable, almost uncanny, uniformity in many aspects of material culture and urban planning, especially concerning their water management. A remarkable degree of standardization in urban planning, architecture, and material culture, including drainage and sanitation systems, is evident across the major cities and towns of the Indus Valley civilization, spanning hundreds of miles. This isn't just a vague similarity. It's a consistent application of specific principles and technologies. It's like they had a franchise model for building successful, hygienic cities. Welcome to Harappa, a proud and fully compliant subsidiary of Indus Urban Living Incorporated. Please admire our standard-issue street grids and our impeccably constructed regulation-depth drains. You'll find similar high-quality amenities at our Mohenjo-Daro and Lothal branches. What does this standardization look like when it comes to their drains and sanitation? Well, you'd see those same kiln-fired bricks, often in those familiar 1:4 ratios, being used for drain construction in city after city. The design of the street drains, covered, brick-lined channels with gentle slopes, is a recurring theme. The presence of private bathing platforms and latrines connected to this public network isn't an isolated feature of just one metropolis. It's found in dwellings across the civilization, the types of terracotta pipes used for smaller conduits, the design of sump pits or collection jars, even the way manholes or inspection points were constructed, often show a striking family resemblance from one site to another. An Indus merchant or artisan traveling from, say, Mohenjo-Daro in the south to Harappa further north would likely have felt remarkably at home, at least in terms of the urban infrastructure. Ah, yes, they might muse, sipping some ancient beverage. The familiar feel of perfectly aligned brickwork underfoot, the reassuring sight of well-maintained drain covers. It's good to see corporate standards are being consistently upheld across the territories. This widespread uniformity has some pretty profound implications. Firstly, it suggests a highly effective system for sharing knowledge, engineering principles, and technological innovations across this vast area. This wasn't a case of each city independently reinventing the wheel or, in this case, the covered drain. There must have been a common pool of architectural and engineering expertise, a well-understood set of best practices that were widely adopted and adhered to. It's like they all downloaded the same Advanced City Planning and Sustainable Drainage Solutions Bronze Age Edition software package from the Indus App Store. And clearly, it was very effective, very popular software. Secondly, it points towards a highly organized society, with skilled artisans and builders who were trained to these common standards. You don't achieve this level of consistency in construction over hundreds of miles and several centuries without a well-established tradition of craftsmanship and a mechanism for transmitting those skills. Whether it was through guilds of builders, itinerant master masons traveling between sites, or a centralized training program, the result was a remarkably consistent urban product. This very consistency, this almost obsessive, in a good way, attention to standardization, extends beyond just drains and bricks. It's also seen in their system of weights and measures, in the types of pottery they produced, and in the oeconography of their famous steatite seals. This has led some observers to humorously imagine a very strict, perhaps slightly formidable, Indus Standards Organization, or Harappan Bureau of Conformity, that rigorously enforced these commonalities with almost comical zeal. Picture the ancient ISO Indus Standards Organization, inspector, clipboard in hand, probably a clay tablet, arriving unannounced at a new construction site. Your street grid alignment is impeccable. Your brick dimensions are, as always, a delight to behold. Your public well placement is textbook. But wait, is that a non-standard curvature on that particular drain junction in Sector 4B? Task. My dear site foreman, that simply will not do. We have civilizational standards to maintain. You know, of course, the reality was likely more complex than a single overbearing bureaucracy. Whether this widespread uniformity in urban systems like drainage reflects a centrally controlled empire, meticulously enforcing standards from a single capital, or a more decentralized network of interconnected communities, voluntarily adopting and adapting best practices due to shared cultural beliefs, extensive trade links, and the obvious benefits of such systems, remains a pivotal and hotly debated question in Indus studies. Perhaps it was a combination. Maybe a few major centers set the trends, and others adopted them due to their evident success. Or perhaps there was a shared ideological framework that valued order, cleanliness, and communal well-being, and this was expressed in their remarkably uniform urban environments. It's also important to note that while the broad principles and technologies were standardized, there would naturally have been some minor regional variations or local adaptations based on specific geographical conditions, available resources, or the particular needs of a settlement. A coastal trading port like Lothal, with its unique dockyard, might have had different water management challenges and solutions compared to an inland city like Kalibangan on the arid plains. However, the underlying template, the fundamental approach to sanitation and drainage, remained remarkably consistent. You don't see a lot of wildly experimental rogue Indus cities with, say, completely haphazard, organically sprawling street plans and, just for kicks, perhaps some avant-garde spiral-shaped drainage systems constructed from seashells. They clearly found a system that worked exceptionally well for their needs, and they wisely stuck to it, refining it over time. If it ain't broke, as the ancient Harappan proverb probably didn't quite say, don't try to fix it with non-standard bricks and a dubious gradient. This uniformity is both a blessing and a bit of a puzzle for archaeologists. On the one hand, it allows them to understand and interpret new sites more easily by drawing parallels with well-excavated ones. We've found evidence of a brick-lined channel with a slight slope here, highly likely to be part of the drainage system, just like at Mohenjo-Daro. On the other hand, it can sometimes make it harder to discern distinct regional identities or track the precise flow of influence. Archaeologists must love it for its clarity and be slightly baffled by its pervasiveness. Everything is so Remarkably similar, they might exclaim, scratching their heads. It's wonderfully organized, a testament to their planning. But where's the delightful chaotic individuality we usually find in ancient settlements? Where are the quirky, local architectural dialects, this uniform flow of ideas, designs, and standards across the Indus realm is a testament to the interconnectedness of their society and the high value they placed on effective urban infrastructure. The fact that a citizen could likely expect a similar level of sanitation and water management, whether they were in a major metropolis or a smaller provincial town, speaks volumes about the priorities and capabilities of this extraordinary civilization. It adds another layer to their mysterious yet deeply impressive achievements in creating livable, healthy, and enduring cities. This uniform flow of ideas, designs, and civilizational standards across the vast Indus realm truly is a testament to the remarkable interconnectedness of their society and the extraordinarily high value they placed on creating and maintaining effective urban infrastructure. The fact that an Indus citizen, whether in a bustling metropolis or a smaller provincial town, could likely expect and experience a similarly high level of sanitation and water management speaks volumes about the priorities, the capabilities, and the shared vision of this extraordinary civilization. And this, of course, adds yet another deeply impressive layer to their achievements in crafting cities that were not just livable and enduring, but also, by the standards of the ancient world, surprisingly healthy. So, let's now consider the profound impact these advanced sanitation systems likely had on Indus public health, turning these cities into what might be described as ancient havens of hygiene. When you think about densely populated cities in the ancient world, or even in much later historical periods before the advent of modern medicine and sanitation, one of the first things that often comes to mind is the ever-present threat of disease, crowded conditions, inadequate waste disposal, contaminated water sources. These were often recipes for widespread illness. But the Indus Valley civilization, with its meticulous attention to drainage and clean water, seems to have been actively, if perhaps not always consciously in the modern scientific sense, combating these threats on a grand scale. Living in an Indus city likely meant a significantly lower chance of stepping in something unpleasant on your way to the market, and probably a considerably lower chance of catching something unpleasant as a result. A definite win-win for ancient feet and ancient immune systems. How exactly did their sanitation systems promote public health? Let's break it down. Firstly, the efficient removal of wastewater from homes and streets, channeling it away from living areas, would have dramatically reduced human contact with sewage and household waste. This simple act of separation is fundamental to preventing the spread of many waterborne diseases like cholera or typhoid and parasitic infections that thrive in contaminated environments. They didn't necessarily need to know about specific bacteria or viruses. The empirical observation that keeping waste away from people generally led to better health would have been a powerful lesson learned over generations. Sometimes, good old-fashioned common sense, born from experience, is the very best kind of science. Secondly, their careful management of clean water supplies was crucial. As we saw, Indus cities were peppered with numerous wells, both private and public, providing access to groundwater. Critically, these clean water sources were generally kept separate from the wastewater drainage systems. You don't find drains emptying directly into wells, for instance. This separation is vital for preventing the contamination of drinking water, which is a primary route for the transmission of many serious illnesses. Thirdly, those covered street drains played a huge role. By enclosing the wastewater channels, they achieved several important things. It significantly reduced foul odors, making the city a more pleasant place to live. A Bronze Age city, even one as well-planned as Mohenjo-Daro, probably didn't smell entirely like a field of freshly bloomed roses on a breezy spring morning. Let's be realistic. But this system would have made a colossal difference. Less eau de médiéval, plague pit. Much more eau de slightly damp earth. Wood smoke from distant cooking fires. And perhaps the intriguing scent of spices from the marketplace. Definitely an upgrade. Furthermore, covered drains would have limited the breeding grounds for disease-carrying insects like flies and mosquitoes, which thrive in stagnant, open wastewater. Annoying for the local mosquito population looking for a prime, swampy breeding spot. Certainly. Curses foiled again by Harapan civic planning and their inexplicably effective drain covers, but a massive boon for human health. And let's not forget those private bathrooms and latrines within individual homes. These facilities would have greatly enhanced personal hygiene and significantly reduced the likelihood of public defecation, another major source of contamination in less well-organized settlements. Having a dedicated place to wash and to relieve oneself, with systems to carry the waste away, is a cornerstone of a healthy living environment. The overall effect of this comprehensive system, well-drained streets, covered sewers, private toilets, and accessible clean water, would have been a much cleaner urban landscape, with far less standing wastewater and accumulated refuse. This, in turn, would have created a far less hospitable environment for the pathogens and pests that cause so many devastating urban diseases. The advanced sanitation and drainage systems of the Indus Valley civilization are therefore widely believed to have significantly contributed to public health, likely reducing the incidence of common waterborne diseases and creating a far more hygienic urban environment compared to many other ancient and even some much later societies. Now, what does the direct bioarchaeological evidence, the study of human skeletal remains from Indus sites, tell us about the health of the population? This is where things can get a bit tricky. Not all diseases leave clear marks on bones, and the preservation of skeletal material over 4 millennia can be variable. However, some studies have suggested that Indus populations, while certainly not free from all ailments, no ancient society may have suffered less from certain types of infections or parasitic loads that are often rampant in conditions of poor sanitation, while direct, irrefutable skeletal evidence is often limited in what it can tell us about specific epidemics or overall morbidity rates. Bioarchaeologists continue to meticulously analyze skeletal remains from Indus sites to better understand patterns of disease, nutrition, and overall health, and to infer to what extent the sophisticated sanitation systems demonstrably mitigated common ancient urban ailments. It's a complex puzzle, and researchers are constantly developing new techniques to coax more information from these ancient bones, trying to tell from a 4,500-year-old femur if its owner suffered from a bad drain or just incredibly bad luck with a poorly cooked meal is, shall we say, a nuanced science. This particular tibia looks vaguely annoyed, perhaps by consistently unsanitary drinking water. Or maybe it just stubbed its toe one too many times. Further research is required. It's also interesting to consider if the Harappans had other hygiene practices beyond their impressive plumbing. This brings us to a rather quirky or fringe tidbit of speculation. Some researchers have pondered whether the Indus people might have actively used certain plants known for their antiseptic, insect-repelling, or purifying properties in or around their homes and drainage systems. For example, neem leaves, widely available in the region and known for their potent medicinal and insecticidal qualities, could have been used. While direct archaeological proof for such practices is elusive, plant matter rarely survives for millennia. It's a fascinating thought that aligns with their evident concern for cleanliness and creating a healthy environment. It highlights a potential layer of environmental hygiene practices that might have complemented their engineering. When you compare the likely health conditions in an Indus city with many of their contemporaries, or even with cities in Europe during the Middle Ages, the contrast is stark. The Indus people were enjoying a level of public sanitation that simply wasn't matched in many other parts of the world for thousands of years. This would have had a direct impact on their quality of life, on infant mortality rates, and on the overall vitality and productivity of their society. Healthy populations can support denser urban environments and can devote more energy to cultural, technological, and economic advancements. We often complain about paying our council tax or municipal fees today, but just imagine if a portion of that went towards maintaining public drains and water systems that actually worked as effectively and comprehensively as these did 4,500 years ago. That's a civic goal worth aspiring to. The Indus Valley civilization, therefore, wasn't just a place of impressive architecture and extensive trade. It was, in many ways, an ancient haven of hygiene, a testament to a people who understood, perhaps intuitively, perhaps through generations of observation, the profound link between a clean environment and a healthy populace. Their commitment to sanitation, engineered into the very foundations of their cities, was one of their greatest, if often unseen, achievements. The Indus Valley civilization, as we've seen, truly was an ancient haven of hygiene, a testament to a people who deeply understood the profound link between a clean environment and a healthy, thriving populace. Their remarkable commitment to sanitation, so clearly engineered into the very foundations of their cities, was undoubtedly one of their greatest, if sometimes underappreciated, achievements. But the water challenges faced by these ancient urbanites didn't just come from within their homes and workshops in the form of wastewater. They also came from above, in torrential downpours, and from the sides, in the powerful, life-giving, yet potentially destructive embrace of the mighty Indus River and its tributaries. So, how did their sophisticated drainage systems and their overall urban planning cope with the often unruly forces of nature, particularly the seasonal monsoons and the behavior of the rivers themselves? Were they just as adept at taming these mighty natural deluges? First, let's set the scene. The Indus Valley civilization, as its name suggests, was cradled by one of the world's great river systems, the Indus, along with rivers like the Sarasvati, which has since largely dried up or changed course. The Ravi, the Sutlej, and others carved out the fertile plains where these cities flourished. These rivers were their lifeline, providing water for drinking, irrigation, and transport. But they were also powerful and, at times, unpredictable. Annual snowmelt from the Himalayas could swell the rivers dramatically, leading to extensive flooding. And then there was the monsoon. The Indian subcontinent is defined by its seasonal monsoon rains, which bring essential moisture for agriculture, but can also unleash immense volumes of water in a relatively short period. For the Indus cities, this meant dealing with both the potential for riverine flooding and the challenge of managing intense stormwater runoff during the monsoon season. The monsoon, absolutely fantastic for the farmers anxiously awaiting rain for their crops, but potentially a bit of an annual infrastructural headache for the dedicated city planners. Right team. One can imagine the chief engineer announcing, looking at the ominous, darkening skies. Here comes several million gallons of unexpectedly enthusiastic sky water. I sincerely hope those drains we spent the last decade perfecting are ready for a rather vigorous workout. So, could those same meticulously constructed street drains that handled daily wastewater also cope with the sudden deluge of a monsoon downpour? In many cases, yes, at least to some extent. Their substantial size, their careful sloping, and their covered nature would have helped to channel away a good deal of surface water from the streets and public spaces. The very layout of the cities, with streets often oriented to follow natural drainage gradients, would also have played a role. However, the sheer volume of water during a heavy monsoon or a major flood event might well have overwhelmed a system primarily designed for domestic effluent. This leads us to look for evidence of larger, perhaps dedicated, stormwater management features. While the distinction isn't always crystal clear, some of the particularly large drains found in Indus cities may well have served a dual purpose, or even been primarily intended for stormwater. It's not just about where your ancient bathwater gracefully exits stage left. It's about where all the rain makes its grand and hopefully swift departure. You certainly don't want your main commercial thoroughfare turning into a temporary and rather muddy public swimming pool every monsoon season. That would be decidedly bad for commerce, terrible for meticulously maintained brickwork, and generally ruinous for one's Bronze Age sandals. And remember those reservoirs and cisterns we talked about, particularly the impressive ones at Dolavira. While their primary purpose was freshwater storage, they also represent a sophisticated form of rainwater harvesting and storm water management. By capturing and storing monsoon runoff, the Indus people were not only conserving a precious resource, but also reducing the amount of water that would otherwise have surged through the city or caused localized flooding. Beyond the drains themselves, other aspects of Indus urban planning suggest an awareness of flood risks. The Indus Valley civilization was situated in a region heavily influenced by the monsoon and the Indus River system, and their urban planning, including drainage, likely incorporated measures to manage seasonal flooding and stormwater runoff, though the extent of dedicated large-scale flood control structures beyond city walls is still debated. Many of the major cities, like Mohenjo-Daro and Harappa, were built on raised mounds, or tells, formed by successive layers of occupation over centuries. This elevation would have offered some natural protection against lower-level river floods. There's also evidence at some sites, like Harappa, of massive mud brick platforms or even perimeter walls that might have served, in part, as flood defenses or embankments. essentially a plan B when the river decided to throw an particularly energetic, watery tantrum. Building your meticulously planned city right next to a colossal river that has a known penchant for occasional, dramatic overspills. You'd be wise to have a plan B, and probably a plan C involving a lot of very sturdy, very well-fired bricks, and a healthy respect for the power of nature. The architecture itself might have incorporated adaptations. For example, the ground floors of houses in some areas might have been used more for storage or functional purposes, with living quarters on upper floors, offering a degree of safety if the streets briefly flooded. The use of those super-durable baked bricks, especially in foundations and lower walls, would also have made the structures more resilient to water damage compared to mud brick constructions. It's interesting to consider the sophisticated relationship the Indus people clearly had with water in all its forms. This brings us to a quirky or fringe tidbit. Many Indus seals, those small, intricately carved stone objects, depict boats of various kinds. There's also archaeological evidence of well-constructed docks, like the famous one at the coastal city of Lothal, and even possible canals. This clearly shows they were masters of navigating and utilizing water for transport and trade. This deep, daily familiarity with the power and behavior of rivers and coastal waters might well have profoundly informed their land-based water management strategies as well. It's as if their whole civilization had a PhD in applied hydrology and advanced river etiquette. So many boats on their seals. Maybe they just really enjoyed a relaxing afternoon cruise down the Indus. Or, perhaps more likely, it was a subtle, constant reminder. We understand water, folks. We live by it. We travel on it. We manage it when it's on our streets. And we respect its immense power. We've got this. The big question for researchers often revolves around the scale of their flood control engineering beyond the immediate city precincts. The degree to which Indus cities actively engineered large-scale flood defenses like extensive regional dikes, major diversion canals miles upstream, or elaborate river training works, versus relying more on strategic high-ground site placement, robust local drainage within the city walls, and perhaps resilient agricultural practices to mitigate flood risks, is a subject of ongoing archaeological investigation and intensive environmental reconstruction, finding conclusive evidence for massive, ancient earthworks across a wide, dynamic floodplain after 4 millennia is incredibly challenging. But their in-city systems strongly suggest they were far from passive victims of their environment. These weren't just fair-weather engineers, content to design systems that worked only when the sun was shining and the rivers were behaving themselves. They were clearly all-weather, all-season water wizards, grappling with the full spectrum of hydrological challenges presented by their environment. Floods, mighty monsoons, unpredictable river surges. You can almost hear their infrastructure whispering back through the ages. Bring it on. We've got carefully calculated gradients, expertly laid baked bricks, and a civic plan that actually considers these things. Well, perhaps the bricks didn't actually whisper that, but their enduring presence and functionality certainly suggest a high degree of confidence and capability. We still struggle with the challenges of urban flooding today, even with all our advanced technology, satellite forecasting, and sophisticated engineering models. Perhaps we could all benefit from taking a closer look at some 4,500-year-old Harappan blueprints, if we could find them, and then decipher them, for some timeless tips on how not to accidentally become a temporary Atlantis during an unexpectedly enthusiastic downpour. The ability of the Indus drainage systems to cope with not just daily wastewater, but also the more dramatic influxes of storm water from monsoons and potential river overflows speaks to their robustness and the comprehensive vision of their creators. They understood that managing water was not just about the gentle, predictable flow from a household bath, but also about preparing for nature's more boisterous and voluminous contributions. The sheer ability of those Indus drainage systems to cope with not just the daily outpourings of a bustling city, but also the more dramatic, voluminous contributions from monsoons and potentially overflowing rivers truly speaks to their robust design and the comprehensive vision of their creators. They weren't just reacting to water. They were actively planning for its many moods and manifestations. But to truly grasp the magnitude of this achievement, to understand just how remarkable their sanitation engineering was, it's helpful to take a step back and see how they stacked up against their contemporaries. What was happening in the rest of the Bronze Age world while the Harappans were busy laying miles of covered drains and installing private bathrooms? This comparison, I think you'll find, really sets the Indus Valley civilization apart, establishing them as a true benchmark in ancient urban water management. So, how did the Harappans compare against the other big names, the Joneses of the ancient world, sanitation-wise, around roughly 2500 to 1900 BCE? Let's just say if there had been a Bronze Age Olympics with the cleanest city and most hygienic infrastructure category, the Indus Valley representatives would have been strong contenders for the gold medal, possibly sweeping the podium entirely. Let's first take a quick trip over to Mesopotamia, the land between the Tigris and Euphrates rivers, home to great civilizations like Sumer, Akkad, and Babylon. These were undoubtedly sophisticated societies, renowned for their cuneiform writing, their ziggurats, their early legal codes, and their complex irrigation canals which were vital for agriculture. When it came to urban sanitation within their bustling cities, however, the picture is often a bit different from what we see in the Indus Valley. While palaces and major temple complexes in Mesopotamian cities might have had some rudimentary drainage for wastewater, often in the form of open channels or vertical shafts leading to cesspits, city-wide, integrated systems for common residential areas were generally less developed. You'd find streets that might have open drains, or wastewater might simply be thrown out, eventually seeping into the ground or flowing into collection pits. Their primary hydraulic engineering focus was often on large-scale irrigation and managing river floods for agriculture, rather than on the kind of meticulous, household-to-street sanitation network that characterized Harappan cities. Mesopotamia had its monumental ziggurats and its incredibly important invention of writing. But their urban plumbing for the average citizen was frequently more a case of hope for the best and try not to live directly downstream from your neighbor's wastewater outlet. The Indus folks, as we've seen, were a tad more proactive and systematic about the whole affair. Then let's cast our gaze towards ancient Egypt, flourishing along the Nile. The Egyptians, of course, were masters of monumental architecture. Think pyramids, sphinxes, colossal temples. Their entire civilization was intricately tied to the rhythms of the Nile, and they developed sophisticated irrigation techniques to harness its fertile floodwaters. But when it came to urban sanitation for the masses, it was often quite basic, while royal palaces, tombs of pharaohs for their afterlife needs, presumably, and the homes of very high-ranking officials might show evidence of bathrooms, simple latrines or channels to carry away water. There's little to suggest the kind of comprehensive, city-wide, covered drainage system serving ordinary residential districts that we find in Mohenjo-Daro or Harappa. For most of the population, waste disposal would have been far more rudimentary. The Egyptians were undeniably amazing at pyramid construction, intricate hieroglyphs, and, frankly, a very strong eyeliner game, but widespread, covered municipal drains for every Tom, Dick, and Hotep. Not so much their top priority, it seems different civilizational focus, different infrastructural plumbing. Now, what about the Minoan civilization on Crete? Contemporaneous with the later phases of the Indus Valley civilization, the Minoans, particularly at palace complexes like Knossos, are justly famous for some impressively advanced plumbing features. We find evidence of terracotta pipes carrying water, elaborate bathrooms, and even what some have described as flushing latrines that used water to carry waste away. Truly remarkable for the Bronze Age. This sounds pretty sophisticated. Right, and it was. However, the key difference often lies in the scale and application. The advanced Minoan plumbing seems to have been largely concentrated within their grand palace complexes, serving the elite who resided there. It was more akin to luxury private installations, a Bronze Age equivalent of a high-end spa experience for the royals and their court, compared to other major Bronze Age civilizations like Mesopotamia and Egypt. The Indus Valley civilization exhibited a far more advanced and widespread system of urban sanitation and drainage, particularly in its application to ordinary residential areas, and not just elite structures. While a Minoan king might have enjoyed a rather well-engineered palace privy, a significant number of ordinary Harappan citizens had access to private bathing areas and latrines that connected to a public, city-wide system. It was a different philosophy. Really, Minoan Crete offered luxury sanitation for the few, while the IVC was pioneering comprehensive sanitation for the many. Different business models, if you will. This brings us to the key distinctions that truly highlight the advanced nature of the Indus Valley systems. Firstly, as just mentioned, the scale and ubiquity. Harappan drainage wasn't just an elite privilege. It was a fundamental feature of their urban design, benefiting a broad cross-section of the population. Secondly, the planning and integration. These systems weren't ad hoc additions. They were conceived and built as part of the initial city plan, with houses and streets designed from the outset to accommodate them. Thirdly, the clear focus on hygiene for a wide populace, implied by the widespread private bathrooms and their connection to public drains. And finally, that remarkable standardization across a vast geographical region, suggesting a deeply embedded cultural and technological approach to sanitation. It's fun to imagine an Indus Valley merchant or diplomat, well accustomed to the relative cleanliness and order of their home city, visiting a major urban center in another part of the Bronze Age world. You can almost picture them, politely trying to hide their surprise, or perhaps a slight wrinkling of the nose. A very impressive city you have here, my esteemed contemporary, they might say. Truly monumental temples, fascinating markets. But, if I may be so bold, it's a trifle fragrant in places, isn't it? And do your citizens often just toss their wastewater directly into the main thoroughfare? Most peculiar. Ever considered the benefits of covered, brick-lined drains with a gentle, consistent gradient? Just a thought, of course. We find it works wonders back in Mohenjo-Daro. This raises an interesting question, though evidence is scarce. The extent to which the advanced sanitation of the Indus Valley was a completely independent, indigenous development versus being potentially influenced by, or perhaps even influencing other contemporaneous cultures, perhaps through their extensive long-distance trade contacts with Mesopotamia or the Persian Gulf, is a complex question with limited direct evidence. Did these civilizations ever compare notes on municipal plumbing designs at ancient international engineering conferences? Greetings, esteemed representative from Sumer. Have you seen our latest iteration of the interlocking terracotta pipe? It's a real game changer for household outflow management. We're thinking of patenting it. Probably not in so many words, but the exchange of ideas along trade routes is always a possibility, even if the Indus system appears so uniquely comprehensive. For a rather quirky or fringe tidbit related to this comparison, while some Minoan palaces on Crete had those impressively engineered latrines that appeared to have used water for a form of flushing, the sheer scale and public utility of municipal wastewater management seen in Indus cities like Mohenjo-Daro was simply unparalleled for its time. The Minoan efforts, while technologically clever for their specific context, look more like bespoke, luxury private installations designed for the comfort of a very select few, rather than the broad public works aimed at citywide hygiene that characterized the Indus approach. It's like comparing a custom-built, gold-plated toilet in a billionaire's penthouse to a well-functioning, citywide public sewer system. Both involve managing waste, but the philosophy, scale, and societal impact are vastly different. So, when you place the Indus Valley civilization alongside its Bronze Age peers, its achievements in urban sanitation and drainage truly stand out. They weren't just keeping up with the Joneses in this particular, crucial aspect of urban living. They were setting a benchmark that few, if any, could match for a very long time to come. Their commitment to a clean and healthy urban environment, engineered from the ground up, remains one of their most impressive and enduring legacies. So, when you place the Indus Valley civilization alongside its Bronze Age peers, its achievements in urban sanitation and drainage truly do stand out, establishing a benchmark that few, if any, could match for a very long time to come. Their commitment to a clean, healthy, and meticulously engineered urban environment remains one of their most impressive and enduring legacies, a testament to their foresight and skill. But, as with all great civilizations, the music eventually fades, the lights dim, and the grand urban experiment begins to wind down. And this inevitably leads us to a more somber question. What happened to these sophisticated systems? Did these vital drainage networks, once the pride of Harappan engineering, begin to show cracks? And did their decline mirror, or perhaps even contribute to, the broader societal collapse or transformation of this extraordinary civilization? We know that the mature urban phase of the Indus Valley civilization began to decline around 1900 BCE. This wasn't a sudden apocalyptic event, but a gradual process of de-urbanization, a shift away from large city living towards smaller, more dispersed rural settlements, which unfolded over several centuries. The reasons for this transformation are complex and still debated by scholars, likely involving a confluence of factors, climate change, including prolonged droughts that would have impacted agriculture, shifts in river courses, particularly the drying up of the Ghaggar-Hakra river system, often equated with the legendary Sarasvati, disruptions to long-distance trade networks, and possibly internal societal pressures or migrations. Even the best-laid drains of mice and Harappans, as the saying almost goes, can eventually go astray, or in this case, get a bit neglected and fall into disrepair when the foundations of the society that built them start to unravel. So, what does the archaeological record tell us about the state of these drainage systems during these later declining phases of Indus cities? The evidence, unfortunately, often points to a noticeable deterioration in civic standards. In the later phases of many Indus cities, there is archaeological evidence suggesting a decline in civic standards, including less well-maintained drainage systems, encroachments on public spaces with shoddier, less planned construction, and a general decline in the quality of building work. It's as if the once meticulous attention to detail, the commitment to public order and hygiene, began to wane. You might find drains from these later periods that are partially blocked with silt and refuse, suggesting less frequent or less effective cleaning. There are instances of makeshift or crude repairs to older, more sophisticated drains, using substandard materials or less skilled techniques. Sometimes, new buildings from later occupation levels are found to have been constructed directly over older drainage lines, encroaching on what were once carefully maintained public thoroughfares and utilities. It's a poignant picture of a system under stress, a society perhaps struggling to maintain the complex infrastructure inherited from its more prosperous forebears. This brings us to a rather telling and somewhat quirky or fringe tidbit that illustrates this decline in standards. In some of these later, cruder drains or patch-up jobs found in the declining Indus settlements, archaeologists have discovered that the builders were using broken pieces of earlier, more finely crafted cultural materials as mere building rubble. This might include fragments of beautifully painted pottery from the mature Harappan phase, or even broken pieces of those iconic steatite seals, now just unceremoniously shoved into a collapsing drain wall as a makeshift repair. It's a powerful, almost heartbreaking symbol of making do as standards slipped, like someone using bits of precious, antique fine china to patch a leaky garden pipe. It speaks of a loss of resources, a decline in craftsmanship, or perhaps a shift in societal priorities away from the meticulous upkeep of their once glorious civic amenities. Now, the crucial question, was this decay in the drainage systems a cause of the city's decline, or was it a symptom of broader societal unraveling? Did the drains effectively give up on the people, leading to health crises and making the cities increasingly unlivable, or did the people, facing other mounting pressures, gradually give up on maintaining the drains? It's a classic chicken and egg, or perhaps more appropriately, a Harappan and effluent kind of question. It's highly probable that it was a complex feedback loop. As societal stresses mounted, perhaps due to environmental changes or economic disruptions, the ability of the civic authorities, whatever form they took to organize and fund the regular maintenance of extensive public works like drainage, would have diminished. it's hard to prioritize the biannual degunking of Drain 7B on North Street when your vital long-distance trade routes are collapsing. Your agricultural yields are plummeting due to drought, and your neighbors in the next valley are starting to look a bit restless and overly interested in your remaining granary supplies. Sorry, citizens. A beleaguered late Harapan official might announce the municipal budget for comprehensive drain unblocking and sump pit excavation has been, shall we say, reallocated to other pressing matters, such as figuring out why the river has moved 10 miles to the west, and whether we should all learn to farm sand dunes. And as the drains began to fail, becoming blocked and overflowing, the cities would have become less hygienic, less pleasant, and potentially less healthy places to live. This, in turn, could have exacerbated social stress, encouraged people to move away to smaller, less crowded rural settlements, and further weakened the urban fabric. So, failing infrastructure likely contributed to the decline, even if it wasn't the sole or primary cause. Environmental changes would have also directly impacted these water-reliant systems. Prolonged droughts, for instance, would mean less water available generally. While this might seem like it would reduce the load on wastewater drains, it could also mean less water available to effectively flush the channels, potentially leading to more rapid siltation and blockages. Conversely, more erratic or intense flooding, perhaps due to shifts in monsoon patterns or river avulsions, sudden changes in a river's course, could have physically damaged the drainage infrastructure, overwhelming channels, destroying outfalls, and depositing vast amounts of silt that would have been incredibly difficult to clear without a well-organized and well-resourced workforce. When the major rivers start doing their own dramatic and unannounced rerouting dance across the landscape, and the seasonal rains either forget to show up for a few decades or arrive with the unbridled fury of a meteorological toddler tantrum, even the most brilliantly conceived drainage plan is going to feel the strain. We meticulously planned for predictable wastewater outflow. The ancient engineers might lament, not for our primary water source to become a dust bowl, nor for our city to become an impromptu tributary of the Indus during flood season. The precise relationship between the observable decline in the maintenance of urban infrastructure, like these vital drainage systems, and the broader socio-economic and environmental factors contributing to the Indus civilization's gradual transformation and deurbanization remains a complex area of research, with ongoing debates among archaeologists and paleo-environmental scientists about primary causes versus secondary symptoms of decline. It's like trying to determine the exact cause of death for an entire civilization. Rarely is it a single, simple factor, but rather a cascade of interconnected issues. What is clear is that the sophisticated drainage systems, once a symbol of Harappan ingenuity and civic pride, did not endure unchanged. Their eventual decline, whether a cause or a consequence of wider societal shifts, paints a poignant picture of a complex urban society grappling with immense challenges. The silence that eventually fell over these once bustling cities, with their slowly clogging drains and crumbling walls, serves as a stark reminder that even the most advanced infrastructure is vulnerable when the society that created and sustained it faces overwhelming pressures. So, no, the drains didn't single-handedly bring about the end of the Indus Valley's urban phase, but a city with increasingly unreliable and overflowing sewers is definitely a less appealing, less healthy, and less sustainable place to call home. Anyone else fancy relocating to that new, smaller village upriver? A late Harappan might have asked. I hear their puddles are considerably cleaner, and they have far fewer arguments about whose turn it is to unblock the main culvert. The cracks in the system, both literal and metaphorical, were becoming too large to ignore. The cracks in the system, both the literal ones in the crumbling, neglected drains of the late Harappan period, and the metaphorical ones in the socio-economic fabric of their society, eventually became too large to ignore. The great urban experiment of the Indus Valley civilization, with its once gleaming infrastructure and vibrant city life, gradually wound down, its population dispersing, its grand cities slowly surrendering to the encroaching silence and the patient work of millennia. But the story, as we know, doesn't end there. For centuries, these magnificent cities lay largely forgotten by the wider world, their secrets buried beneath layers of earth and time. Then came the archaeologists, spade and trowel in hand, ready to unearth this lost urban ingenuity and, in doing so, revolutionize our understanding of ancient South Asia. For nearly 3,000 years after its decline, the Indus Valley civilization remained a ghost, a whisper in the landscape, while local populations in some areas undoubtedly knew of the existence of large ancient mounds, the tells formed by collapsed mud brick and baked brick structures, and perhaps even had their own folklore surrounding these cities of the ancestors. The scale, sophistication, and true identity of this vast Bronze Age culture were largely unknown to global scholarship. The history of ancient India, for many, was often thought to begin much later, with the arrival of the Aryans or the rise of the Mauryan Empire. The Indus people, with their undeciphered script, had left no easily readable historical accounts to announce their presence to subsequent literate cultures. There were, of course, tantalizing early encounters. In the 19th century, British engineers building railways in the Punjab, like the Cunningham brothers, noted vast quantities of ancient baked bricks being plundered from a large mound near the village of Harappa to be used as ballast for the railway tracks. They recognized the antiquity of the site, collected some of the enigmatic carved seals, but the full extent and nature of the civilization remained elusive. Initial puzzlement, rather than comprehensive understanding, was the order of the day. The real breakthrough came in the early 20th century, with the advent of more systematic archaeological excavations. The systematic excavation of Indus cities like Harappa, starting significantly with Daya-Ramsani in the 1920s, and Mohenjo-Daro with R.D. Banerjee in 1922, followed by Sir John Marshall and others, revealed the unexpectedly advanced nature of their urban planning and sanitation, including those extensive drainage systems, which significantly altered the understanding of early South Asian history. Imagine being one of those pioneering archaeologists. You start digging into what appears to be just another large, unassuming earthen mound in a dusty, sun-baked landscape. And then, your trowel hits something hard, something regular. Not just a random stone, but a perfectly formed, kiln-fired brick, then another, and another, laid in a precise line. And as more earth is carefully brushed away, a channel begins to appear, then another connecting to it. Then evidence of a covered drain running beneath what was clearly once a street. Well, now, That's not what I was expecting to find under this rather large and unassuming lump of dirt. You can imagine them exclaiming, "This looks less like a primitive village and more like a meticulously planned city with some seriously impressive public utilities." The discovery of these sophisticated drainage systems, in particular, must have been an absolute aha moment. Here was evidence, clear and undeniable, of a civilization that possessed an extraordinary level of engineering skill and a profound concern for public hygiene. Thousands of years before such amenities became common in many other parts of the world, including much of Europe. The first detailed reports from Mohenjo-Daro and Harappa, describing the grid-planned streets, the substantial houses with their private bathrooms, and, most astonishingly, the city-wide network of covered drains and elaborate wells, would have sent shockwaves through the academic world. The initial reactions probably included a fair amount of disbelief, followed by sheer wonder. Found ancient city. The early telegrams or dispatches might have cryptically announced, surprisingly clean. Excellent plumbing. Appears to be Bronze Age. Send more tea, biscuits, and perhaps a larger budget for shovels. Unearthing these systems was a meticulous and often challenging process. These drains, wells, and bathing platforms were fragile structures, buried under many feet of accumulated debris from centuries of decay and later, more rudimentary occupations. Archaeologists had to carefully trace the lines of brickwork, document the different layers of construction and silt, and try to understand how the various components interconnected. Excavating ancient drains, not always the most glamorous or sweet-smelling part of archaeology, perhaps, but absolutely vital for understanding the daily life and technological capabilities of the Indus people. Mined the Bronze Age sludge. Jenkins. One can almost hear a senior archaeologist cautioning a less experienced digger. It's historically significant sludge, and try not to break that perfectly preserved terracotta pipe with your overly enthusiastic pickaxe. Interestingly, and this is a rather nice, quirky, or fringe tidbit, early excavators sometimes found that local lore and traditions about hidden cities or mounds of the dead, as the name Mohenjo-Daro literally means in Sindhi, actually helped guide them to these significant archaeological sites, while scientific survey techniques were, of course, paramount. These folk memories, passed down through generations, sometimes held a kernel of truth, pointing towards places where great settlements had once stood. It's a beautiful example of how local indigenous knowledge can sometimes intersect with and even assist formal scientific pursuit. Always listen to the local elders and their stories. They might just know where the 400-500-year-old metropolis with the world-class plumbing system is buried. The discovery of this urban ingenuity, particularly the drainage and sanitation, completely revolutionized prevailing views of the IVC and of ancient South Asian history in general. It pushed the timeline of complex urban civilization in the subcontinent back by many centuries, if not millennia. It powerfully challenged the then common colonial narratives that often downplayed or ignored indigenous achievements prior to European influence or Aryan migrations. Here was clear, tangible proof of a highly advanced, indigenous urban culture that had mastered complex engineering and city planning on a grand scale, long before many other recognized ancient civilizations had reached comparable levels in these specific areas. Finding these drains, these planned cities, was a bit of a mic drop moment for ancient Indian history. Oh, you thought civilization in this part of the world started much much later, and was perhaps imported from elsewhere. The Harappan ruins seem to say, "Well, kindly hold my remarkably well-preserved and hygienically functional terracotta drainage pipe while we reconsider that notion." This process of discovery and reevaluation is, of course, ongoing. Later excavations at other Indus sites, both large and small, have continued to reveal more examples of these sophisticated water management systems, confirming their widespread nature. New scientific techniques, such as remote sensing, geoarchaeology, and chemical analysis of residues, continue to add finer details to our understanding of how these systems functioned and what they can tell us about the environment and daily life of the Indus people. However, the exact timeline and precise methods of initial archaeological recording for some of the finer details of the drainage networks during those early, groundbreaking 20th century excavations, and consequently, how much nuanced information might have been inadvertently lost before the advent of more modern, meticulous recording standards, is sometimes a point of careful re-examination and constructive critique by contemporary researchers. Early digs, driven by the excitement of major discoveries, were sometimes, by today's standards, more about enthusiastic clearance than painstaking, layer-by-layer documentation. Let's clear this whole area out quickly. Look, another beautifully constructed drain, the pioneers might have exclaimed. A modern archaeologist, while deeply respecting their groundbreaking work, might gently sigh and mutter, "But did you photograph it from 17 different angles? Take multiple soil flotation samples for micro-debris analysis, and GPS tag every single brick before you moved on." Progress in archaeological methodology is a wonderful, if sometimes retrospectively frustrating, thing. Nevertheless, the unearthing of this urban ingenuity, particularly the surprisingly sophisticated drainage systems, remains one of the great archaeological detective stories of the 20th century. It transformed our understanding of a lost civilization and continues to inspire awe at the achievements of these ancient city builders who, thousands of years ago, engineered a remarkably clean and well-ordered world for themselves along the banks of the Indus. Nevertheless, the unearthing of this widespread urban ingenuity, particularly those surprisingly sophisticated drainage systems, remains one of the truly great archaeological detective stories of the 20th century. It utterly transformed our understanding of a long-lost civilization and continues to inspire a profound sense of awe at the achievements of these ancient city builders who, thousands of years ago, engineered a remarkably clean, orderly, and well-serviced world for themselves along the fertile banks of the Indus River. But beyond just admiring their past accomplishments, what is the enduring legacy of these lost loos and subterranean streams? What lessons can we, in our hyper-modern, technologically advanced world, still glean from the Harappans' approach to sanitation and urban living? The first part of their legacy is simply the acknowledgement of their extraordinary technological achievement for their time. The sheer scale, planning, and engineering skill demonstrated in their water management systems, the private bathrooms, the public drains, the wells, the reservoirs, represent a pinnacle of Bronze Age urban infrastructure. It stands as a powerful testament to what human societies can accomplish with available resources, keen observation, and a strong communal vision, long before the advent of power tools or computer-aided design. Their work continues to challenge any lingering, simplistic preconceptions about ancient societies being universally primitive or lacking in sophisticated technical capabilities. The Indus people were clearly operating on a very high level of practical intelligence. Beyond the purely technical, there's a cultural legacy too. The emphasis they placed on cleanliness, on public health, on providing such amenities not just for an elite, but for a significant portion of their urban population, speaks to a deeply embedded cultural value. This concern for communal well-being, for creating a hygienic environment, wasn't just a byproduct of their planning. It seems to have been a fundamental principle. And this is where we find surprisingly relevant lessons for our modern world. The principles of urban planning and sanitation evident in the Indus Valley civilization, such as integrated drainage, dedicated waste management systems, and ensuring access to clean water, offer valuable insights and striking parallels for contemporary challenges in sustainable urban development. We, today, grapple with issues of water scarcity, pollution, effective waste disposal, and the public health implications of rapidly growing cities. The Harappans, in their own way, were tackling similar problems 4.5 millennia ago. Consider their approach to sustainable urban planning. The very idea of integrating essential services like drainage into the initial layout of a city, rather than trying to retrofit them later, is a crucial lesson. How many modern cities suffer from infrastructure that can't keep up with expansion, precisely because that long-term, integrated vision was lacking at the outset. The Indus people seem to have understood that a city needs to function as a whole system. Their focus on public health infrastructure is another timeless takeaway. The clear link they established, whether intuitively or through experience, between sanitation and a healthy populace is a lesson we are still reinforcing globally. Access to clean water and effective waste removal are fundamental human rights and the bedrock of public health. The Harappans, with their wells and their covered drains, were, in essence, pioneering public health engineering. We have our supercomputers, our advanced medical science, and our nanotechnology. And yet we still face immense challenges with blocked drains, overflowing sewers, and providing equitable access to clean water and sanitation in many parts of the world. Maybe we need to hire a Bronze Age Harappan consultant. Your current municipal wastewater plan seems a trifle suboptimal. Have you considered the strategic implementation of really good baked bricks and a consistently gentle, gravity-assisted slope? The way they managed water in what was often an arid or semi-arid environment with highly seasonal rainfall also holds relevance. Their construction of wells to tap into groundwater and reservoirs like those at Dolavira for rainwater harvesting demonstrates a keen understanding of water conservation and the need to secure supplies for dry periods. As modern societies face increasing water stress due to climate change and growing populations, these ancient strategies for capturing and storing precious water offer food for thought. The Harappans were unknowingly, or perhaps knowingly, eco-chic. They used local durable materials like baked brick, designed systems that were built to last for the most part until the Great Decline, and showed a remarkable capacity for adapting to their environmental conditions. Very trendy, even by today's increasingly stringent green building standards. And let's not forget the lesson of simplicity and durability in materials. those standardized baked bricks, fired for strength and water resistance, formed the backbone of their infrastructure. It's a reminder that sometimes the most effective solutions are those that use readily available local materials in an intelligent and robust way, rather than relying on overly complex or imported technologies that might be difficult to maintain in the long run. Perhaps one of the most profound, if less tangible, lessons lies in the implied sense of community and civic responsibility. These citywide systems couldn't have functioned without a degree of communal effort, adherence to common standards, and an organized approach to maintenance, whether it was individual households ensuring their private drains connected properly, or a more centralized body overseeing the public works. There was clearly a collective investment in making their cities livable. Of course, there's still so much we don't know. The biggest missing piece of the puzzle is their undeciphered script. If only we could read their writings. Imagine the texts we might find. Chapter 1. Top 10. Tips for totally tubular toilets and terrific terracotta pipes. Or perhaps. Chapter 2. Sump Pit Secrets Your Neighbors Won't Tell You. A Harapan Homeowner's Guide to Odor-Free Living. The Lost Self-Help Guides to Bronze Age Sanitation and Urban Bliss. While their drains and wells speak volumes about their practical skills, their innermost thoughts, their philosophies, their detailed social organization remain tantalizingly veiled until that script yields its secrets. This brings us to a rather intriguing, quirky, or fringe tidbit that bridges the ancient and the modern. It's said that modern city planners and water engineers occasionally look to ancient systems like those of the Indus Valley civilization, not for direct, literal copying, of course, but for inspiration regarding the underlying principles of holistic design, long-term thinking, and the integration of infrastructure with urban life. It's like an ancient consultation across the millennia. Right. A 21st century engineer might muse, poring over diagrams of Harapan drains. This basic design for a gravity-fed, covered channel with accessible sump pits looks remarkably efficient and surprisingly sustainable. Now, how can we adapt that core concept for a megacity of 10 million people, ensure it's earthquake-proof, and maybe integrate some smart sensors and Wi-Fi connectivity into the manhole covers, the extent to which the specific social and political structures of the Indus Valley directly enabled or were themselves shaped by their unique and widespread sanitation achievements, and precisely what lessons this complex interplay holds for modern governance and the successful implementation of large-scale public works today remains a fertile ground for ongoing interdisciplinary discussion and scholarly research. What kind of leadership, what societal buy-in, what economic capacity allowed them to achieve this on such a grand and uniform scale? These are questions that still resonate. Ultimately, studying these ancient systems, these lost loos and forgotten waterways, does more than just satisfy historical curiosity. It connects us to fundamental human needs, the need for clean water, for a healthy environment, for well-ordered communities. It reminds us that ingenuity and the drive to improve our surroundings are not solely modern attributes. At the end of the day, everyone, in every era, needs a good drain. It's a fundamental human constant. Right up there, with eventually needing a reliable Wi-Fi connection and occasionally complaining about the weather. The Harapans, with their baked bricks and their bitumen, their carefully sloped channels and their public wells, tackled this fundamental need with a level of sophistication that continues to command our respect and spark our imagination. Their enduring legacy is not just in the silent stones that remain, but in the powerful example they set of a civilization that understood the profound importance of water and engineered their world accordingly, as our journey through the surprisingly sophisticated drainage systems of the Indus Valley draws to its gentle conclusion. Let the image of these ancient cities, with their orderly streets and their hidden networks of water, linger in your mind. Imagine the bustling life they supported, the hum of a civilization that, for a time, mastered the art of urban living in a way few others in the ancient world could match, the sheer ingenuity of their engineers, the communal effort of their builders, the foresight of their planners. All these elements combined to create something truly remarkable, a testament to human capability that still echoes down through the millennia. The baked bricks, now weathered by time, still whisper stories of a people who valued cleanliness and order. The dry channels, though no longer carrying water, still trace the paths of a once vital system. The deep wells still speak of a relentless quest for life's most essential resource. Though their script remains a mystery, their actions, their constructions, speak volumes about their priorities and their understanding of the world. As the soft shadows of evening lengthen in your own space and the world outside quiets down, perhaps you can feel a faint resonance with those ancient city dwellers, their concerns for health, for community, for a well-ordered life, are not so different from our own. The Indus Valley people, with their remarkable drainage systems, remind us that the foundations of a thriving society are often built on such practical, yet profoundly important achievements. May their ingenuity inspire a sense of wonder, and may their silent, well-drained cities flow gently through your dreams tonight, a reminder of the enduring power of human creativity and foresight. Sweet dreams.